So we're gonna go over this stove here that was in the competition about 2 weeks ago. Problem is that the oven was not self-cleaning, and when we attempted to self-clean, the oven would not lock the door. And was there any code on the stove when you guys did that?
Yeah.
What did it say?
F90.
F90. So I don't have the codes up there, but F90 said what? Do you remember?
Door latch.
The door latch assembly. So let's go ahead and plug this in, Costa. I have the back of the stove off. So I'm gonna go ahead and press self-clean and press start. And did you guys hear the clicking?
Mm-hmm.
What was that?
Switches.
There was what?
Relay.
Relay where?
The board.
Okay, relays on the board, and these black boxes here are all relays on the board. So that one relay you heard when I pressed start is the relay for the lock motor to tell the oven, go ahead and lock for self-clean. Right now the door's not locking, and right here is our lock mechanism. The motor's underneath. We have a switch, and this piece rotates around, moving a lever on the front to lock the oven door. Let's go ahead and look at the schematic and identify those particular parts here. We got over here our lock motor. How much power does that lock motor get?
120.
Excuse me?
120.
How do you know that?
These are online and vote on Mitchell.
Well, this line right here is what?
Line one.
Line one. If you follow it all the way in, it comes here. This is power to the board. And it's line one. We got two lines here. What is this one?
That's line two.
That's line two. It comes to the board. It says line two in. And this one here goes to the motor, but it also goes here to the board. And it doesn't say it here, but if we look at this diagram here, this is a picture of the board. It tells you what the different relays are. This is the bake element relay, the broil element relay, DLB double line brake relay. These three control the element. And then that's the motor relay right there. And then this is the plug that plugs right here on P5. And if we look here, lock motor, and then that one pin, 1, 2, 3, 4, 5, is the neutral wire. I know it's a little hard to see, but that's neutral. So if we went back to this diagram and went 1, 2, 3, 4, 5, that is my neutral line coming in. So if I knew that this was neutral, here, it also goes to my motor. If I'm gonna put neutral to it, the motor can't be 240 volts. Could the motor be low voltage, like 24 volts or 12 volts?
Yes.
Raise your hand, I can't hear you.
That's a yes.
What do you think?
I think it could, but wouldn't we have to have a transformer on there?
Well, transformer could be built onto the board.
Good.
If we look right here, that is a transformer on the board. But if it's connected to neutral, it's not gonna have, it's either gonna be 120
Yeah.
or that's it. If it's connected neutral, neutral is the main power source for the stove. So it's gotta be 120. It can't be 240 because 240 doesn't go to neutral. And it can't be low voltage. If it was low voltage, it'd be a wire coming off the board, and then the other wire may come back. And the two wires would go to the board, but not to neutral. Okay, so if you know a part goes to neutral from a board, one wire comes off the control board to a part, and the other side of that part goes to neutral, it's 120 volts. Okay, so that lock motor here, that lock motor goes to neutral here and goes to the board right here. Where is that motor most likely getting its power from?
On the board.
But where from the board?
Line one.
Probably line one. So line one comes in and it goes through two relays to feed the elements, but somewhere on the board is another relay and it comes down here and it sends power to that motor. Alright? Now we went and pressed clean. Did you guys see if this black part was rotating?
Didn't.
It wasn't rotating. Okay, so this motor wasn't rotating. Now before I go through testing the component out, remember I said we have a switch over here next to the motor. That switch, we got two switches here. Which one of those switches is it? We've talked about this before.
The lock.
The lock
The lock
switch.
switch.
It's the lock switch. This one is called what?
Door
Door
switch.
And what does that door switch do?
It checks to see if the door is open or closed.
Yes, that door switch is activated when you open and close the door. That piece I'm hitting right there is the door switch, and the control board will not even turn the motor if this switch is not closed. Okay? So could this switch be bad and the lock motor not work?
Yes.
Yes. Okay. So how do you know if this switch is good? We could test it, but another way to check it out would be what?
See if the light is on. and
Open the
stuff.
door and see if the light comes on. If you open it up, sure enough, I know you guys can't see it. I don't want to rotate the stove. You guys can see the light there?
Yeah.
Well, the reflection off the wall.
Okay, yeah, you can see down there that the light's coming on. So if the light's coming on and off, what does that tell you about this switch?
It's open and closed.
Switch is good, right? Now this switch we'd have to test out. What's the purpose of that switch? If you want to answer, raise your hand. Okay, say yell it out. But what is the purpose of this switch? Yeah, Dudley?
It's a safety switch, so when you're cleaning it, because it have a high temperature.
No, it's not the high temperature. Yes, Ross.
It's because it's at that temperature for such a long period of time that nobody's gonna sit there and watch it the whole time. So to keep that safety there, to keep all the heat in.
No, not that switch. That is this temperature probe, the oven sensor. This is in the oven. This is telling the board the temperature. Okay? But this switch is activated when this black piece of plastic rotates around.
Yeah,
So, what do you think the purpose of that is? Anybody else?
it's to lock the
Oh.
door.
To let the board know that the door's locked.
To let the board know whether the door is locked or unlocked. The motor's gonna rotate, but the motor doesn't actually communicate to the board what position it's in. So when we lock the oven, the motor rotates. This plastic piece has got a little button on the end, and it pushes on that switch, and we go in the cell clean. But that switch does not control whether the motor runs or doesn't run. That switch tells the board, where is the motor? Is it in the unlocked or the locked position? Yes, Mario.
Yeah, it's like these two switches look like in parallel to me, no?
These two switches?
Uh,
Well, one switch is if the door's open, it won't let the motor run.
So it's in series.
The other switch is telling the board, and that goes from this wire here to this wire here. These two are communicating to the board, hey, the door's locked or the door's unlocked or whatever. So when the motor rotates, it's gotta know when to stop. And so that's what that switch does here. Okay? But this motor's not working. We wanna know, okay, what is my problem? How should we go about testing this unit? Anybody?
Well, I assume that we go ahead and put 1, 2, 3, 4. We put our leads on pin 6 and pin 5 to check to see if we have any sort of voltage coming out of there.
So you're saying 6 and 5, these two here?
Yeah.
Because this is 1, 2, 3, 4, 5, which is neutral,
Yep.
and 6 would be what?
That would be.
Line 1. Okay, we could do that, but what I'd like to do, we're already back here, is it would be easier to do what test?
A voltage test on the lock motor
Take out
itself.
the
No,
wires.
go ahead.
Yeah, check power to that particular motor.
Go check power right to this motor. Put a voltmeter right on those two wires. If I have power there and the motor doesn't work, then what do? Change the board? Change the motor. If I don't have power, then I would go to 5 and 6 and see if the board is sending it out. So if I don't have it here, this is the first test I want to make. If I don't have it here, I want to know if it's coming out. Because I could have a broken wire here or here. not giving me power to that motor. But usually if you're testing a component, and something as simple as board or motor, okay? You wanna go right to the component that's not working and say, hey, does that component have power? Okay, if the power's there or not. Right? Yes?
Yeah.
Oh,
Yes,
looking at it, I don't know.
Absolutely.
Yeah.
Okay, the only time you don't wanna check power directly to a component is one, if the motor's spinning and it's got belts or transmissions moving around, and your hand in that area is gonna be unsafe to make that test. Or the voltage, like a microwave, is so high, you don't wanna check voltage to that part because it's so high. Now, do any of you guys got your gloves? Yes, no? I need someone to do a voltage test here, but you gotta have your gloves. Gonna do a voltage test, Russ? No?
Only hurts till it stops, right?
Oh, it hurts till I unplug it.
So, only hurts till it stops.
Okay, so we're gonna set the motor to volts AC. And what we wanna test are the two wires supplying power to this motor, this white and this brown wire here. So we're gonna go ahead and test power right to here. What do we have to do to test that power? Yes,
I just wanna go ahead and point out that the multimeter is wigging out right now.
okay, well, let's see if we got voltage there. If not, we'll switch meters. So we're on volts AC, and what do we gotta do now? We gotta start the self-clean cycle, so I press self-clean, I'll press start. Do we have any voltage?
Yeah.
That one's not right.
Yeah,
So you're touching the two wires?
I'm trying.
Check black and white there just to make sure the meter's reading properly. Okay, so it is 117, so go back there and figure out a way to touch those two wires.
Okay.
So we have 117 volts here, right? Okay, so now what do we do?
And the motor.
Change the motor.
Change the motor. Can you ohm it out?
Yeah.
What's the point? Okay, let me ask a question. Are you done testing the motor? Are you done testing the stove?
Yeah.
Because just because you have voltage and it's not working doesn't mean you have the switches around it that are, or bad wires.
Well, it's not so much
No.
the switches, but what if something mechanical is jamming the motor up? That motor is so small, it's not like a washer motor that's jammed up. You're gonna hear that motor humming. You know, so what you wanna do is you wanna make sure that this piece is not physically jammed up. Because if it's physically jammed up, the motor won't turn. Maybe the motor's trying to run, but the plastic or the metal's stuck somewhere, and you go and order a motor and it's not the motor. Yes, Ricky?
I had a situation where it wasn't locking. The hook that hooks into the door, it was bent.
Mm-hmm.
So I replaced it because it was wore out over a period of time, so it wasn't the motor. But I looked at how I was trying to hack.
But it couldn't turn because the piece was bent.
It was bent to the, like toward the frame of the.
Yeah, it was bent down against the metal and it wasn't allowing that lock mechanism to move.
Yes, sir, so I replaced
So
part.
that was basically a simple problem. How many of you guys found that in the competition? Y'all did?
Yes, I did.
You find it, Jervinsky? No? You got it, Fausto?
I wanted to go ahead and point out here though, because, I didn't check for voltage specifically into the motor itself, but I went ahead and ohmed it out and I noticed that it was an open line. So that's how I.
That's okay to ohm it out, but you wanna know that the board is sending power.
Yeah,
That motor could have failed, but maybe the board's not sending power either. So you wanna know if you're getting power to that component, and if you have power, what does that mean? That the board's okay. If I have power here, that means the board's sending power, the neutral's good, there's nothing more left but the motor. And it's that simple as far as troubleshooting out. It wasn't like, oh man, it could be this, it could be that. Yes, the door switch, if you open and close the door, if that switch was bad, the motor would not run. But if that door switch was bad, what would happen?
You'd see the light on all the
The
time.
light would stay on. So, I mean, that would be an indication, hey, wait a minute. That's the door switch, that's not a bad motor. So checking voltage to a component, as long as you can do it safely, that's the first way to go. Put your meter on the component's not working with the wires. You don't take the wires off in voltage, only in ohms. I've had someone checking a microwave. I said, you got power to the transformer? The guy goes to me, no, I don't got no power to transformer. You said, sure, let me go take a look. And he's got the meter with alligator clips attached to the transformer, but the two wires that are supposed to bring power, they're here in the air. I said, well, how do you get power if you take the wires off? So when you guys test, you have to know what it is you're testing. So this is very simple here. If you got power here and this motor's not running, motor's bad. Very simple. Yes, sir.
Are those two switches are in series with each other?
Not really. They're just using this one terminal as a common terminal to the board. So in other words, I'm gonna do the two separate circuits here with different colors. Okay, this terminal here comes into this switch, comes here and goes right back to the board here. All right. If you look at this terminal here, it comes to this switch and it comes right back to the board here. So there's probably a positive and negative or a low voltage here, and this is the common terminal, but it sends a voltage to either one of these and it comes out the other side. And the board is just looking at that circuit or this circuit. Almost like your water level switch had 3 terminals but had one common side. The board is using that to watch what those switches are doing. It looks like they're in series, but it's not sending power like this through both of them to work. This one and this one are doing 2 different things. A good question. Anybody got any questions on this? I know it was simple and you're like, man, that's all there was? But that's all there was to this problem. You guys should have found this. The longest part should have been taking the back panel off to make the test in the first place. Yeah, poor Carlos, huh? Any other questions?
Where's the door switch located?
Which one?
The door switch.
This one?
Yes, sir.
This one is located right here in the front.
Okay.
Look, watch the light.
Yes, sir.
Now, in some of these, this switch is located right in the front. You see these 2 wires right here? That's that door switch, okay? But it runs all the way to the front here. Some of these has the button here, but it's a metal rod that goes all the way to the back and the switch is back here. So when you're pressing it, even though you would think the switch is right here, it's just a metal rod running to the back of the stove and hitting the switch in the back. But these 2 wires here are the door switch wires. There's 2 pink wires. If we look at this diagram right here, the door switch is right here, 11. It doesn't tell you the color,
Is that pictorial?
but that's the door switch. What?
Is that pictorial diagram?
Well, it's not an actual diagram. It's just a picture of the board and the plug that connects to the board. It's not the whole diagram. But yeah, it is pictorial in a way as it shows you all the relays and tells you what they are. Okay? Because it's not telling you which one of these relays is for the light. But you don't change the relay. If one of those relays failed, you change the whole board anyways. Any questions? Alright, if I can get it together tomorrow, we're gonna do the dishwasher diagram. Alright? So, we'll get that one done tomorrow. And Thursday, you can cut the